Hello everyone and welcome back to Urban Informatics and Modeling, and this is Josh. For today we'll be covering about sun-subtracto. What is sun-subtracto? It's a Boolean method or method of cutting a volume using solder pathways. It's very useful for massing and form finding, and it's very useful in the context of creating a public space and urban design. So let's go to the Food for Rhino to download the plugin and just search for Ladybug. See, I have searched for Ladybug before. Just search of it, and the first item that pops out here, that's the first thing that you want to take a look. So Ladybug, you see there are 4 different images over here. So Ladybug tools, there is not only consists of Ladybug, so they have also honeybee, dragonfly, and butterfly. But for today we'll be covering about Ladybug only because that's related to solar analysis and sun-subtracto. The rest of them will be related more towards wind analysis and other environmental system. So scroll down and go to this download tab, and it has a lot of versions over here. So sometimes it only has one, sometimes it has a lot of versions because they keep updating the tools, and that's great. And you want to download this one here because that's the latest tool. So just download it and it creates a zip. And then what you want to do here is just to make sure that this is going to be installed in Grasshopper, but it's different from other components in Grasshopper because this thing here, the plugin, is actually in user file. As a user file, you can see it's an orange rather than the green one. So it's located in a different folder. And what you want to do is just to go to Grasshopper, File, similar to the other ones, but instead of going to component folder, you need to go to user object folder. And there you go. This is where you want to put your Ladybug and honeybee and butterfly plugins and user objects. I've already put it mine. So let's go open up the file. Okay, so right now I've already opened up the file for my project, which is in Dananong, and this model here that was created by Elk is another plugin for Grasshopper where it downloads and it imports the data from OpenStreetMap. That has been covered in another video. And for today we'll be covering about the sun-subtracto and sunlighting. So first of all, select the site. So this is our site, our selected site, and that's the building footprint. And what you want to do is just to have the Ladybug tools on. So this is the Ladybug tab, and make sure every time you work on Ladybug, this is on, because that's how Ladybug is actually being. That's the activation component for Ladybug to run. And if you don't have this one, then other Ladybug tools will not run. So in Ladybug, you want to have, that's the visual weather data, and Ladybug sun path, and it creates the location. So the thing with Ladybug here is that they also need like a weather file, and you can import the file. So the file is in EPW. So it's quite similar to Elk, but it has a different kind. It has a different kind of input. And what you want to do is just to insert the file path, just connect it there, and select one existing file. So I've put it here, EPW file, and EPW, this one here. Now there are two different EPWs here, and I want to choose this one because this is the latest one, and that one is quite old. So this is based on the airport, and it's more accurate. So it's imported, as you can see here. So it doesn't show any warning. And what you want to do is just to connect all the dots. Okay, so I've already connected all the dots, and I've already connected all the required information from this component to to this component. So you need the north, and in this case, the north is always in y-axis. And the location is imported from this component, the EPW file. The hour you want to do this, you want to do in 24 hours. And the way this works is not like, for example, if you want to have an analysis from 7 to 9 a.m., you do not do 7 and 9 because this is more like a series and a count. So this is a series. It's a different kind of method in doing it. I'll show you why. Because for example, if you want to do it in 7 to 9, so you change the start to 7, but you change the count to 2. Because how series works is that it's going to count from this number. So that's the original number. That's the starting number, and then the step between one number and the next number, which is this one, which is 1. It's inputted as 1, so it means every hour. And count means that how many numbers that are going to be produced. So here you can have 7 and 8. That means that this is inclusive. So what you want to do is just select 3, and it produces 7, 8, 9. So that's how you, if you want to do the analysis from 7 to 9 only, so you have to do this step. So it's a very different thing, and it's not as straightforward as 7 to 9 and 7 and 9. Because if you do the 7 and 9, it's going to calculate the sunlight path from 7 a.m. to 3 p.m. in the afternoon. So if you want to put it for the whole day, just put 1 as a starting point and 24 as a count, and it's producing from 1 a.m. to 12 a.m. in the morning. And then the next thing is the day and month. So the day and month is actually, you want to do it in either equinox, which is March or September, 21st of March and 21st of September, the winter solstice, which is the 21st of June, and in summer, you want to do it in the summer solstice, which is 21st of December. So because we're in Australia, the summer is in December and winter in June, and if you are in Northern Hemisphere, it's going to be in different dates. So make sure you want to check with that one. Okay, so, and the next one is the time step. So time step is that, it means that how many step per hour did you want to input. So time step is actually the amount of step you want in an hour. So if you, for example, if you put the time step as 6 like I do here, it's going to calculate the sun position every 10 minutes. So 60 minutes divided by 6, which is 10. So every 10 minutes it's going to record the sun path. And moving on, that's the center point of the sun path. So this area here, that's the location of the area that you want to provide the sunlight, or if you want to have a look at how the sun would behave in that, and how the sun would affect the site. But since we are doing sun-subtracto, this is the site where you want the sun to be allowed to go through. So for this instance, this is the site that's selected. So if you can see here, and if I make a preview, see that this is highlighted green, which means that that's the site that I want the sun to be allowed to go for. And then that's a center point because it requires a center point. And well, with doing this, the result is that the sun diagram, the sun path, will be centered at this point. And this is sun path scale, just to make sure that the diagram is visible. And if you want to have a look like what it looks like, it's going to be like that. So north is over there. that's the angle where that's the angle of the bearings, and that's the east, and that's the sun path. So right now at the yellow bits, that's the sun in this condition. That's the sun in this condition. And every hour, it provided 6 different sunlight. So 1, 2, 3, 4, 5, 6. That's 1 hour, and then the next hour is over here. Next hour is over there. So that's how it works with the sun diagram. So if you want to change, for example, to, I'll just preview this one. So for example, if you want to change it to summer, just press 12, and it's going to be changeable here. And if you want to do it in winter, that's how it looks. So for now, just change it to September as an equinox. You can do it in March as well, but the location is actually the same. So how do we do the sun-subtracto then? Sun-subtracto, it has a little bit of, there are various of ways, but I think this is the best. But I think this is the best one to look for, because the first way is just to use the solar fan, which I will show you later. And the second one is to use the area solar fan. So the difference is that the solar fan, the regular solar fan, is going to produce like from a one point where you want the sun to go to be allowed to go through, whereas the area affects this whole area over there. So the reason why I think area sun-subtracto is much better, because it allows this whole area to be provided with sunlight, and whereas if you do it in a single point, there will be some areas that are still dark, and it's not going to cover the whole lot of the area that we want. So that's just why area sun-subtracto is always better. Is better. So how do we do that? The first thing is to make sure the sun positions, which is those, and from the center point here, we want to extrude this curve here to every single sun position, and that's going to be the aerial solar fan, and that's going to cut the building. So after I find the sun position, make sure it's have a line from this to this point over there, so just like that. So if you're doing the non-aerial solar carving or sun-subtracto, that's done. That's actually finished, and you can have the solar fan like that, and you can cut the building. But the problem is, just like I said, this area will still be dark, because you only cut the building until this solar fan over here. So that's why in most cases area is better. So just delete that, and for this one we use extrude, just like so. Excuse me. Just like so. Extrude the base, which is the curve, to the sunlight like that. So you see that's a solar fan that based on an area. So doesn't really matter if the area is not, like for example like that's quite flat, but it doesn't really matter. And then what you want to do is just to cap it and make it one single volume. The reason why you want to do it in the one single volume, because you want to cut it, we want your building to be cut with this one, and if you have different volumes, if you have more than one volume, and it's going to be failed in Boolean, and the Boolean method will fail. So that's the thing with Boolean method, you need to make sure that it's 1 and 1. One volume minus one volume. So for the building part, as I said, this is the building footprint. Make it as a curve. I like to do the building from Grasshopper, because if I want to change something, I can just change the curve and it's already all recorded. And then just use this part here, Z, and change it to make it 100. So that's going to extrude this curve into the building that's 100 meter high. So the units in Grasshopper is quite different from units in other softwares, because the units in Grasshopper, it depends on the units in Rhino. So for example, if in Rhino you do it in meter as I do, every single number here is going to have every numbers here is going to be one in meter unit, and you want to make sure that you use meter for this case because you're dealing with an urban stuff and you don't want to do it in millimeters. So that's that. So that's our building, and that building will be cut by this building. So just use solid difference, which is the boolean. So A minus B. So that's a principle. So building A, component A minus component B. And if we, oops. Now make sure that this is a closed wrap. This is a closed B wrap. If you have a look, that's an open B wrap. That's why this doesn't work. And that's how it looks. But you don't want the building to be floating like that. So you want to select only the bottom part. So just use the list item. And usually it's the first item in the list, which is item number 0. But that depends on how you make the building at the first place, because we're making the building from bottom to up, bottom to the top. So that's why the bottom part is number 0. But if you do it all the way around, the top part will be number 0. And then just do that, and then you have it. That's the meshing that is produced by the sun-subtracto. So if you want to take this further, you can do the sun analysis, and in a minute I'll show you how it works. Okay, so I've already made the sun analysis components, and you can download this from Ladybug website. They have a lot of scripts that we can use, and that's how I did it also. And then edited just a little bit, just to make it similar to the context that the project has been worked on. So what I did over here is just to bake this model, just to make it easier, and it's much easier to be inserted in the sun analysis. So that you don't really need to be worried about that, because that's sort of like the legend parameters. I'll show you what it means later, but you need to worry about that. So that is actually a script. That is why I recommend you to download it from the Ladybug website, because this script is not in the Ladybug tools. So that's that. Alright, so I've already made the components for sun analysis, and the way I did it is to download it from the Ladybug website. They have a lot of scripts that you can use and utilize. The reason is that because this component here is actually a Python script, so it's not a component from Ladybug. It's a Python script, and you really don't want to do a Python script. So as you can see here, there's no component that shows this component here, sunlight hour analysis. Oh, I actually have. Okay. All right, ulang dari awal. All right, so I've already made the components and the algorithm for the sun analysis, and you can also download it from Ladybug website, and that's what I did as well, because that's much easier. And the Ladybug website, they have a lot of scripts that you can use and copy. So that's how I did it, but I also tweak it just a bit, just to make sure that it is appropriate to my project. So that's a similar thing. So what you want to have a look at this is run it as false, because that's the button to run the simulation for the sun analysis. You do want to keep it false, or else if you keep it true and you change everything's going to be changed incrementally, and it's going to load up your grasshopper very much. And I do recommend to do parallel, because the way Rhino and Grasshopper works is that they use only a single core. It depends on your processor as well. Processors, they have commonly they have 4 right in these times, but AMD But things like AMD, they have like about that can go up to 8 cores and 8 and 16 cores, and it depends on your processor. But I think it's better to turn on the parallel because to utilize all the cores that you have, and it's going to be much quicker. Another thing, just to easen up and lighten up the grasshopper calculation, is to increase the grid size. So the way it works is that it produces a mesh, and the mesh is in grid size. So each square, it denotes the temperature or the amount of sunlight that is received throughout the day. So the bigger the grid size, the less calculation that it does. But it's going to be non-accurate, and it's not going to be really that accurate. So I recommend that in the initial stage you do make it big. Probably that's around 10 meters, okay? So geometry and context. So geometry is the surface. So you can say surface of the, for example, the surface of the land, where you want to know where the shadow is cast whatsoever. And the context is the building that affects the shadow. The north is just the north. So how do we do this? Is just to have a look at this first, because you need to make this geometry in the XY axis. If you rotate this geometry, this is not going to work. The simulation is not going to work, so you need the plane or any surfaces in the X and Y axis, just to make sure the mesh is in perpendicular to the original coordinate system. So let's start the simulation and see how it looks. So after a while, this should pops out. So after a while, after you've pressed through, it's going to solve by itself. It's going to calculate, and it took me 5.5 seconds. And that's how it looks. You can see that it's quite pixelated because the number of the grid size is 10. And if you make it lower, it can be more high resolution, but it's going to take longer. So that's how it do. What it does, the geometry is displayed here, as you can see. So you can see that the amount of sunlight, the amount of shadows cast to the area, and the context is actually the building itself. So here you can see how the building that is sun-subtracto, that has already been affected by sun-subtracto, allows the sunlight to get in here. And if you want to do more detail, I recommend to use the buildings in the context side to geometry. So what it does is to show how many buildings and how is the shadow is cast to the other buildings, just like so. So this is really useful to in urban and architectural scale, because you can see how much overshadowing that your building is affecting other buildings, and it's really useful because you can sort of see the parameters of the thing that you're working on. So because of the sun-subtracto, you can see that this is yellow. It means that it has a high amount of hours. I'm not really sure why is this happening like that. It has never happened before. Usually it's only about 15. Maybe it's because of that. I'll just delete that in a minute. Yep, so that's how it looks. So this part here, you can see that it has 12 hours, more than 12 hours sun exposure in September times. So that's how you do the sun-subtracto. And if you want to do it in winter, for example, you want to allow the sunlight to go in winter, especially in public spaces, just change this to 6 and everything will be changed. So I'll just let you see it for a while. And if you want to go for more high resolution, just change it to 1, but you need to wait more. Okay, so as you can see, the boxes are smaller because the grid size is getting smaller as well, and it's more high resolution. So this gives more detailed information on how the shadow would work, but it takes a longer time, twice the time. So you can see here it took me about 2 minutes to calculate it compared to 5.5 seconds, and that's about 24 time. That's about 24 times longer. So that's how you do this analysis and sun-subtracto. So it's really useful in public spaces, and it's really useful if you want to have a meshing studies. So I hope this is very informative for you, and thank you very much for today, and that's all.